We're about to practice addition and or subtraction of angles and segments. Since segments are a little bit easier to envision, let's start with the segment question, even though it's number 4. One of the problems or challenges of addition of angles is that it differs a little bit from addition of segments, because addition of segments and the union of segments are pretty much the same thing. If we take BE segment, which is over here, and we add it to AE segment, which is over here, we get all the points from A to B. However, when we speak about the points from A to B, we're really speaking union language. If I unite all the points from B to E with all the points from A to E, I get all the points from A to B. That's what union does. What addition really focuses on is measurement or length. So what I'm really saying in problem number 4 is that if I take the length of BE segment and add it to the length of AE segment, I'm going to get the length of AB segment. That difference between focusing on the points and focusing on the measurement is what makes the difference in addition of angles. So now let's look at number 1. In problem number 1, we're asked to add the points, add the angle ADE, which is over here, A to D to E, and again, I'm only drawing segments in the picture, but we already know that angles are infinite, so technically my pointer should have started out here, gone through A to D, turned around and hit E, and kept on going. But since we're mostly interested in what happens at the vertex of an angle, I'm not really overly concerned with the points on the rays out here. Let's focus on the points close to the vertex. Angle ADE, if we were doing union, would take the points on this segment or ray and this segment or ray and unite them with this segment and this segment. And what I get would be a 3-pronged picture. That's not what I'm interested in when I do addition. When I'm interested in addition, I'm interested in the measurement. So when I do angle A to D to E, I'm really interested in the measurement or the space or the width inside. When I do angle E to D to C, I'm also interested in the space inside. So what I'm asking in this addition question is if I go across angle ADE like this and continue across angle EDC like this, what space do I get? All the space in here. And if I get all the space in here, what angle am I spacing? Answer, ADC. Hence the answer down here, angle ADC. And again, I could have said angle CDA. I have no idea why I didn't. But if you want to call it CDA, please feel free. Now let's look at number 2. In number 2, I have 2 missing angles that together make angle AEC. So let's look at where angle AEC is located. Here's A to E to C. Always make sure that the point in the middle is the vertex point. And you start on one side, go to the vertex, and continue on the other side. So when we're asking about angle addition, we're really interested in the space inside angle A to E to C, which is all this space in here. Because we have this segment, or technically a ray, in the middle of the space from A to E to C, we have our opportunity to make an addition problem out of it by breaking up that trip and going from here to here first, and then continuing from here to here. In order to describe this motion of going in this direction, I'm going to call this doing angle AED. So the first missing angle could be angle AED. After I finish doing the space from A to E to D, I want to continue with the rest of the space I need, which means doing the space in here, and that's the space inside of DEC, and the second angle in my addition problem is DEC. I could have gone backwards in this direction and done DEC or CED first and ended with DEA or AED. It's sort of alphabet soup when you do these things, and it's really your choice. I tend to be alphabetical, it seems to me, and I also seem to prefer starting on the left and going to the right. So even though DEC is not alphabetical, I probably did it because D was on the left and C was on the right. You do what you like to do. Now let's look at number 3, which is angle subtraction. I'm basically telling you what angle I ended with, B to C to E. So I ended with this space, but I'm telling you that I got that amount of space by removing this space from D to C to E. So if I removed this space and ended up with this space, I obviously started with all this space. I started with all this space. I removed this and ended with this. And all this space is DCB or BCD, and here it is DCB. Again, please don't mistake the fact that BCD does look like a perfect corner, but as a little bit of a review thrown in free of charge, I'm reminding you that although we can assume that this angle uniting EA and EB into this angle is a straight angle, and my pointer is now making a 180-degree motion, I cannot assume the same thing about BCD. It may look like a perfect corner, but your book does not allow you to make any assumptions about that because it could be 89 degrees, it could be 91 degrees, and you wouldn't know the difference. We already talked about number 4. I'm going to leave number 5 for you. Just locate BED and locate BEA. And again, even though BEA is this, I'm now making a line motion with my pointer when technically speaking, when I do angle BEA, I'm basically doing this to this and then this to this as if it was an angle. And what is the missing space? If BED goes till here and BEA goes till here, what am I missing? I have this already. I want this. What am I missing? All right, I gave it away. The angle I'm missing is DEA. Page 2, like the remaining sheets, there's 3 and 4, contain different diagrams that you will see throughout your geometry textbook. And I made addition and subtraction, mostly focusing on angles because they're more challenging, but I also included segments, and a little section here at the bottom on the differences between using equal signs and congruent symbols when working with angles. All the answers are here at the bottom for you to look at. I think I've talked enough for now. So I hope you enjoy the rest of this ditto, and please feel free to ask me in class if you have any questions about any of the remaining pages so that you're clear on how to add and subtract angles and how to use the measurements of the angles to find answers to challenging geometry questions. Good luck.